Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be taking a look at tar and zip files. Previously we looked at tar files in the last video, but there were a couple issues with that made it so it wasn't really working and I wasn't really happy with it. So we're going to do a redux right here where we're going to cover it more in depth and also cover some more examples that can allow you to use it more versatilely. So let's get right into it. All right, so here we have our same installation that we've been working on this whole time. It's Alpine Linux, and it's running on a Raspberry Pi. And if you want to see how to actually do the installation for that, it's very straightforward. But we have a video for that. I'll put a card in for it right here at some point. But as far as the actual commands that we're going to be covering today, we're going to be doing tar and zip. And we're going to cover how to compress and decompress the files. And for the case, starting with tar, we're going to do actually doing the uncompressed version and the compressed version, just so we can kind of see the difference between the two. So I have the terminal up right now, which is SSH to the Raspberry Pi. So starting with this, there's a couple of flags that I just want to cover first. Okay, and just I didn't go over the meaning well enough last time, so I just pre-chose some choice ones that we can take a look at. So if we do tar -- help, it will give us the list of available commands that we can use for it. All right, and first one is C for create, X for extract, T for list, and then we have -F, which is for defining what the file is, either the input or the output, the actual archive file itself. And then from there, you'll actually see that based on the actual long form definition of what the tar command is here, we have the tar file listed, but then we actually have the list of files that we want to input into the file. So that's the reason it needs a special flag in order to be able to do that. If you don't specify that, it won't actually generate one. Next thing is scrolling down here is V for verbose. That will give us it'll tell us what it's doing as it's doing it, which is really helpful in terms of understanding if it's doing what we expect it to do. The next is Z, which is right here, the lowercase z, which is using gzip compression. There is a regular compressed one that's the capital Z, but it's not as efficient as the gzip. And you'll actually see gzip is quite efficient. And in some cases, we can do a comparison, but it'll be more efficient than the zip file itself. But you use that for both extraction or compression and extraction. And then this other one, which is K, and it's don't replace existing files. And this is very useful for if you're actually going to be taking a backup of something and then restoring it. You don't necessarily want it to replace files of the same name, things like that. So it will prevent it from doing that. So just wanted to cover those basic flags. I think it'll kind of help set the context, but we're going to apply a number of them, pretty much most of them right now. So first, let's create a basic archive. So what I've done in preparation for this is I've created a directory which is called test1 folder. And inside of that, we have 4 files. And if we take a look at one of those files, I just have some lorem ipsum content in there. And that way, it's just going to fill the file with something that is not a 0 size. And I think that'll make it a bit easier to be able to visualize exactly what we're doing here. So if we actually look at it, they're about 2.8 kilobytes each. So that should be a good sample. And if we just do a du-h on test folder, we can see it's totaling about 16 kilobytes on the disk. Just because of block size, there's a 4K minimum. But so there's 16 kilobytes within there, and we're going to try and make that more efficiently stored using a tar file and a zip file, etc. So starting with tar, the command we're going to use in order to actually to make the archive, and all this is going to do is just to make a basic archive where it's just going to bundle it pretty much within a single file. It's not going to do any additional compression or anything else like that. So we're going to do tar-c for create, v for verbose, and f for the file. And we're going to put f last just because we're going to have to define something after it. So if anything came after it, it would cause problems. So -f, and we're going to call this test1.tar. Then we need to specify the source folder, which is test1 folder, right? And now we can hit enter. And when we do, we see test1 folder, as well as its 4 containing files, are all now contained within that tar file, at least as it's advertising. So we've created a regular archive. If we do ls-lh again, we see that it's showing up at about 15.5 kilobytes. We saw earlier that it's about 16 kilobytes in the raw files, but it's 15.5 when it's in the tar file. Reason for that, of course, is because it's in a single file, so it can use potentially fewer blocks. But in this particular case, and it's possible it may be 512 byte blocks, but realistically, it's using less space because it's a single file. But we can also move it around like a single file. So if there are a lot more files in play, this would be extremely useful, and it maintains the hierarchical structure that we had originally when we took the archive. So now let's create a compressed archive. And it's a very similar command. So it's tar, but then we add the letter Z for compression, for gzip. And then we do cvf, just like last time. And we're going to call this one test1.tar.gz. And gz is the extension indicating that it is in fact compressed. And then once again, we put our folder definition for what we actually want to put into the archive. We do that, and again, we see that all the contents of that folder and the folder itself have been included into this new archive. So if we do ls-lh, we see a huge difference in the size. So one is 15.5 kilobytes. The other is 1.4 kilobytes. So a huge amount of space savings, and especially with text files, you know, these are easily compressible because especially I put the same text data in all of them. So there's a lot of opportunity for it to be able to effectively compress it. So across all of those, it was able to boil it down to 1.4K. So let's say we actually wanted to list the contents. We know, or we think we know, that it actually saved the files that we want, but let's verify that. So the way that we can do that is actually using a command, the -t for list. So we're going to do tar-tvf. So we want T for the list, V for verbose, F to specify our file. And then we just put in the name of our file. So let's start with test1.tar. And we see the contents and the sizes of the files when they're uncompressed. Right? So 2,841 bytes for file 4, 3, 2, and 1. But we see that all of the files are there, as well as the modified date, things like that. Let's do the same thing for our compressed file. And we see the contents are the same. So very useful. Now we verified that we actually do have contents in these files and that they are, it is what we expect. But now it comes time to actually use it. So what we want to do is we want to extract these archives. And because it's going to have the same relative folder, we want to just do it to a separate folder just for now because we're testing it, just to verify that it is in fact extracting the way we think it is and check the files out. So first, let's make a directory. So we're going to do make dir restore basic. All right, because we're going to do the .tar, which is the uncompressed version first. So we'll do restore basic. Then we're going to cd into it just because it's going to be easier. Right? It's currently empty. When we ls and it doesn't show anything at all. So now we can untar it. So we'll do tar and then -x for extract, v for verbose, f for file name, and we'll do test1.tar. But because it's not in this directory, we do ... which takes us up one level, which is where we have it. Right? And that's the end of the command. So we run it, we see that these 5 items, right, 1 folder and 4 files have been extracted. And if we ls now, we see the test folder is there. And if we ls-lh, the test folder, we see that we have our 2.8 kilobyte files are restored. Excellent. So let's cd back to our main directory here, and let's extract the compressed version. But one thing I just want to highlight is that when you actually do the extraction, files and folders with the same name in the directory that you're writing to will automatically be overwritten with the tar file. So you would use the -k to avoid overwriting files. And that's Nala right on cue. Let's see. She wants to go out.
Sunroom door open.
Now you don't want to go out. What do you want to do? Come on. It's okay. Woo-hoo.
Sunroom door closed. Sunroom door open. Sunroom door closed.
It's cold out, so she wants to come in and out constantly. So, all right. So, yeah. So you'd use -k if you didn't want to automatically overwrite when you're extracting. So, very important command to know. So let's actually extract the compressed version of this archive. So first thing we're going to do is let's make a directory. Okay, and we're going to call it restore compressed. We're going to cd into that again. Okay, and we ls, there's nothing in there. We just made it. So let's untar it by doing tar -z, because z, of course, is gzip. So we're indicating that it's gzip compressed. And then we'll do x for extract, v for verbose, f for file, and then we do test1.tar.gz. And again, because it's in one directory higher than where we currently are, we'll do the ... Hit enter, we see it extracted it. When we ls, we see the folder is present. And when we ls-lh into that folder, we do see our files are now restored. So it successfully expanded the 1.4, whatever it was, kilobytes of compressed data into the 16K of uncompressed data. So worked as expected. So pretty much going on from there. Let's see. So I'll cd back out of this, and I'll just show you some other useful functions. So in the event that you wanted to create another archive that only had choice files in there, and you wanted to give the files by name. So let's say we went into yeah, so we'll cd into our test folder, okay? And here we see our 4 files. Let's say we wanted to archive or place into the archive 3 of the 4 files. So what we can use is tar -cvf, and again, C create, V verbose, F for file. We're going to call it test2, and I'm actually going to put it one directory higher, just so they're all together. Test2.tar, and then we're just going to specify it, file 1, file 2, and file 3. Hit enter, we see that those files are copied. We didn't have it in a folder or anything else like that, so it's just those 3 files alone. So now if we cd back to our original directory, and we do ls-lh, we see this one that's 11.5k is test2.tar, which is the one that we just created, and that's our new archive. So let's take a look at what's inside and verify what we think we have in there. So we'll do tar -t vf test2.tar. And it gives us the list of files that it has, which is file 1, 2, and 3, which is what we specified. Perfect. But it's not compressed. So let's say we had an existing tar file that we wanted to compress in order to save space. Okay? What we can actually use is a program called gzip, which is just the baseline of what tar is actually using in order to compress the related files. So if we just do gzip and then the name of the file, in this case test2.tar, we can hit enter, and when we do ls-lh, we see that it has now been changed to a .tar.gz file. Now, I do want to point out, it did eliminate the original .tar file that was uncompressed. So it replaced it with the .tar.gz file. So that's important to keep in mind, is use it wisely, because it can potentially destroy data if it doesn't work. But this is actually the same .tar.gz as we were looking at in our example earlier. So if we wanted to, we can actually extract it again. So we can do tar-z-xvf test2.tar.gz, and this will just extract the files right here. So when we ls-lh, we see that file 1, 2, and 3 are now present in this directory. So it was able to extract it using the existing tar, but we were able to split up the archiving function of packaging everything into a tar and then the compression of the gz for gzip into 2 separate operations. So you don't necessarily have to do them at the same time, and that's especially helpful if there's a speed issue or if you've already taken a number of tar archives and want to save space later on. So that's pretty much what we're going to cover for tar. But those are the base functions that you can use to utilize it to be able to get the most out of everything. And I'm going to let the cat in again, otherwise she's going to keep meowing throughout this entire thing. So, and then we'll hop into zip archives.
Sunroom door open. Sunroom door closed.
And say hello. Say hello. Boop, 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 boop. She's going to sit on my lap, I think. That and or climb all over my keyboard. So we're going to see how this goes. All right, so let's clear the screen. And then I'll just ls in here. I'm going to remove some of these files just to clean up a little bit. Just going to get the microphone all covered in here. All right, so let's clean up. We'll do file. We're going to do an rm-r restore. All right, and then we'll remove our tar files. It's okay. Oh, we had a test too. All right, so now we're back to pretty much where we started. I'll clear again. I will spell it right and clear again. And now we'll move on to zip archives. Wow. okay. It's gotten cold outside, so she's, of course, having trouble adjusting to just being inside. She's an indoor-outdoor cat, so. So the first thing that we're going to do is on Alpine Linux, on the default distribution, zip is not actually installed by default. Tar is, but in order to start using zip, we're going to have to install it. So we're going to do apt add, excuse me, I've been using Ubuntu a lot. apk, excuse me, add zip. Now in this particular case, I've already gone through and installed it, just because I was testing all of this earlier, so we didn't see it actually install. But there's two programs that it's going to install. The first one is zip, and the second one is unzip. So it gives you both directions by default when you only request one of them. And, works perfectly fine. And we'll go through and we're going to use both of those. So just like we did before. So for zip, I'll do --help, and we'll go through a couple of the choice options. So first one is D, which we're not going to use here, but you can actually delete files from the archive without unzipping everything and recompressing it. So it's very useful in terms of being able to modify it after the fact. So you're not having to, go through a lot of extra steps. Second thing is for -R. So by default, it won't recurse. It will only do what you specifically say. So if you put a folder name and you don't put -R, it will actually just archive the empty folder. And that can definitely be kind of annoying, so it's very important to check your work. But -R will alleviate this by actually going through and recursing into directories the same way that tar just operated by default. Going on from there, we have X, which is exclude. So if you wanted to not archive certain names, you can exclude it with -X and then a list. You can also do T, capital T, to test, just similarly to how we did with the tar file, to be able to verify that the archive is actually readable and usable. Which, as a minimum, I would say always do that. Just always verify that your archive works. Then it also offers some additional options like encrypt. So you can encrypt with a password the actual archive itself to try and protect the data that's there. U is update only, which is very useful, especially if you're restoring it back. It will only, well, in this case, like let's say you're taking a large backup, okay, and you only want to do changes. You don't want to do every file that's there because maybe not a lot of things have changed. Like especially if you're archiving assets for video production, for example. Your source media may never change, but your project file will continually change. So in order to make that process faster, you can use the -U command, and it will compare the actual timestamps of the last change to each file, and then be able to only update the ones that have changed. So it's a really good way to actually make long processes to go a lot faster by not duplicating work that's already been done. Next is M. So M is, it will delete the original file. So if you're going to archive something and you don't want to see it ever again, you can use -M to be able to do that, and it will clean up after itself. So if you're especially doing like sparse moves into it, that's very helpful in terms of just making sure you're not losing track of what you're doing and double archiving things. But again, it poses the risk of if something goes wrong during the process, you could potentially lose data. So just keep that in mind. And then the last thing is going to be V for verbose, which does the same thing as the last time, which will pretty much print out what it's doing as it's doing it most of the time. So we'll go through it as we need it. But so we're going to go through the same kind of example set again. So we're going to do zip -R for recursive, V for verbose, and then we'll put the name of the archive and then the name of the file. So we'll do test1.zip And then the folder that we want to actually include is test1 folder. Hit enter. We do see that everything came in. We were able to deflate the size by 58%. And the compressed size, if we do ls-lh, is about 5.4K, which is bigger than the compressed file that we had with GZ. So again, GZ is a bit more efficient than zip, but again, zip is a lot more universal in that you can create and expand those natively on Windows. And pretty soon you'll be able to also read tar and tar.gz files on Windows in the next version. But as of right now, zip file is the most compatible. So, you know, it is a bit of a less efficient, but you know, if that's your needs, it's going to be the best case for you. So we've created the archive. Let's test it just like we did the last time, because we created it. We don't necessarily know what's in it. Let's make sure. So we're going to do zip. We're going to do -t, capital T. We'll do lowercase v for verbose. And pretty much all that we'll do in this case is give us a list of files opposed to just saying it's okay. And then we put in the name of our zip file. And we see here, it's okay. It went through, tested each individual file, said it's okay, and then it says it's okay. If we don't put the V, it is a more condensed output, but it just says it's okay. But that's kind of what it's doing in the background, is it's going through and it's testing each individual file to make sure that it's actually, you know, going to work when you try and use it. So going on from there, let's actually uncompress it. Let's put these files somewhere, just like we did with the tar files. And to do that, we're going to use unzip. So before we get into unzip, let's go through a couple of those flags. So we'll do unzip -- help. And when we look at here, some that I've chosen, V again for verbose. L is list the files. So if we wanted a list of files that were present, we could use that for that. -T, lowercase t for test. So for some reason they made it different than zip. I don't know why, but it's a lowercase t, and that will verify it. F is for freshen existing files. So effectively, if the file does not exist, it's not going to create anything new. It's going to just replace files that exist if the timestamp on the zipped file version is newer than the file that exists. So if you go through and you have a bunch of files that you want to update something all to the same version, but somebody made a change in it after the zip file was created, it will not replace it. So that's what that is, but it won't create anything new. So if it doesn't exist there already, it's not going to try and create that file from scratch. So there are applications for that, but again, your needs will dictate what actual commands you need to use. And then -O is overwrite the files without prompting. So pretty much that's what we're looking at. So let's go through a couple of examples. First, we're going to list the contents, right? Because we just created our zip file. So let's list the contents of it. So we're going to use unzip, and we're going to do name of the archive. I'm sorry. Skip down. Unzip -L for list, and then the name of the archive. And that will give us a list of files, the sizes, and the date it was modified. And in this case, we see it was 7/6/2023 that it was created. I fixed a date issue on this or after that, but that's the date stamp that it believes it was created. And we see the total sizes, everything else like that. Wonderful. So we know it's there. So now we want to go through and we want to actually extract it. So let's make a directory called restore zipped. And let's extract to there. And if we just do ls to that folder right now, we see it's empty, right? Nothing up my sleeves, you know, magic trick kind of thing. So we're going to make files appear, you know, say abracadabra. So it's unzip, and then the name of the archive. So test1.zip. Then we put -d in order to specify our destination directory. So this is the only one that has to come after the file name. All the others can go before. But -d, and then the name of the folder where we want to put everything. So we do that. We now see that it has restored everything. So it created the test folder, which is the folder that it had within there, and it put it in restore zipped, right? And then it created all 4 files in that same folder. So now if we do the same command that we just did, we see test folder exists. And if we actually look inside of test folder, we see our 4 files exist. Just for fun, we'll do -lh, and we see the 2.8 kilobyte files are now present. Perfect. So now we've extracted our zip file. So let's say we had something, you know, let's say it was financial information or something else like that that we wanted to protect. And we wanted to make sure that prying eyes weren't necessarily going to look at it. You know, we could encrypt using the native encryption function in zip, which granted is not very secure because you can brute force it pretty easily. But if it's, you know, if it's somebody unskilled or you just want to keep people from inadvertently looking at it, excellent method to do. So let's create a zipped file that is encrypted. So we'll do zip, and we'll do -r for recursive, v for verbose, e for encrypted. Then we're going to call our archive test encrypt .zip, because again, in this case, because it's a native function, it doesn't need a separate extension. And then test1 folder, which is our source files. We enter, we get prompted for the password. I'm just going to put in very simple password that I will remember until we unzip it. So I entered the password, it deflated it the same amount, and if we ls-lh into the directory, we see it's only slightly bigger. Again, because of the encryption, it adds a little bit of entropy as well as some other things like that, like keys. So, you know, it's important to keep that in mind, but it's not going to add a very significant amount overall. So that's great. Let's test it. So let's go and do zip -t lowercase v, so for test and verbose, and then we'll just give it the name, space, give it the name, right, test encrypt.zip. We hit enter, it asks us for the password, right? So it sees that the folder is there, but the actual individual files are what are encrypted, and it needs this in order to be able to actually go through and test each individual file. So once we enter it, then we can see that it's okay. If we were to exit out of it, it would not actually be able to validate that it was in fact readable. So very important step. But again, it also confirms that our password is effective in terms of securing our files. But of course, if you have critical folder names for something, for some reason or another, it will not protect those or the names of individual files. So just something to keep in mind, it will only protect the contents of those files. So let's actually extract it, which is the final thing that we're going to do for today. So to extract the encrypted zip, let's create a directory. We're going to do make dir, and we're going to call it restore encrypt. And we're going to do pretty much the same exact thing that we did the last time around. We're going to do unzip the test encrypt.zip, which is the name of the archive that we want to do. We'll do -d for the destination directory, and then we'll do restore encrypt. Hit enter, it's going to prompt us for the password once again. We enter the password and inflates it. Excellent. We'll do ls-lh, restore encrypt. We see we have our test folder. We go into there, and we see our 4 individual files that we originally had in that archive. So that takes us through the entire process and shows a number of ways that we can go through and be able to create both tar archives and everything else. Let me switch back here. So yeah, so you could use this to definitely back up all your files, which I recommend you do often, as well as be able to create portability, version backups, anything else that you want in order to be able to do it. Be sure to check out the other videos in this series about learning Linux, especially with Alpine Linux, as there's a lot of opportunities for doing things like embedded applications and things like that, and a lot of the commands and everything else also translate over to other variants of Linux operating system and other flavors. So if you like the video, be sure to hit that like button and leave a comment down below. And be sure to share it with a friend. It definitely, if you appreciate this content or you think they'll appreciate it, I will appreciate you for sharing it. And if you haven't subscribed, please subscribe. It helps me out a lot, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.